Hello student, welcome our channel the physics point. And in the previous lectures we have started discussions of the mechanical properties of solids. In that lectures we are saying about the solids. Solids have the definite size and shape. If the solids have the changes their size and shape on the basic of that parameters, we are again classified the two types of these solids. This is known as the plasticity. It is the property of solids, and elasticity is one another property of the solids. On the basic of the changes, the size and the shape of the object, we are classified two properties of the solids. One is elasticity, another one is plasticity. Whenever we apply certain force on that object, it will be changes their size and shape, or at a time both. This is known as deformation. This process, the process in which we apply certain force on that object, and this object will be changes their size or their shape, or at a time both. This property or this phenomenon is known as the deformations. The applying force is known as the deforming force. If the body is comes its original positions after the removal of deforming force, this body is known as plastic body, or this property is known as plasticity. And a force which can be opposed to the deforming force, or which is responsible for the comes their original bring the original size and shape of the object, this force is known as restoring force, which has created inside the object. Certain object which does not comes in original positions or original size, shape, or both after the removal of deforming force, these properties of the solids or these object is known as the plastic object. The next, for applying certain force on the area or unit area of the object, we apply certain force on the unit area of the object. We are taking the example of sponge. This is called as, or we are taking the examples of rubber band. We apply certain force on that rubber band, it can be changes their positions. We apply certain, their changes their size, the changes will be their shape. This is known as the deformations. But we apply certain force on the particular area, applying the deforming force particular per unit area is called as stress, and stress is responsible for the deformations. But another one parameters or another one properties, another one factors will be discussed in the previous lecture. It will be strain. Strain, it is the ratio, it is the ratio change in dimensions of the object to the original dimensions of the object. It is the ratios in which the ratios of the change in dimension to the original dimensions of the object after the applying certain deforming force. And this is the lecture number 2 on the mechanical properties of solids. Mechanical property of solids. This will be lecture number 2. In these lectures, we are starting discussions of the types of stress and types of strain. How many types of stress or how many types of strain? I will be again revise the definitions of stress and strain. Stress, the applied force per unit area or applied deforming force per unit area is called as stress. Strain, it is the ratio in which the change in dimension to the original dimension. This is the strain. This is the strain. But we are taken three different examples. We taken the rubber bands or a string, a metal string. When we apply certain force longitudinally or lengthwise, then will be changes their length. This one are examples. Another one example is if we applying certain force on the surface of the spherical sponge ball, the volume of the spherical sponge ball will be changes. This will be volume stress, volume strain. And again one, if we are taken a box, that is cubic box or cuboid box, we are sprays on the box is tangentially. We are applying certain force on the box will be tangentially. The box will be bent. I will be giving one of the examples here. This is our box, chalk box. When we apply the force on like this, the box shape will be changes. Shape of the box will be changes. This is known as another types of the stress and strain. We are mainly discuss three types of the stress and strain in this lecture. First one is the longitudinal stress. Longitudinal stress and strain. In these types of the stress and strain, the deforming force is responsible for the change in length. Deforming force. This will be deforming force applied along the length. Applied along the length of object. The deforming force is applied along the length of the object. It means the length of the object will be changes, but the stress, the longitudinal stress, denoted as L dot S. This is the longitudinal stress is applied force per unit cross-sectional area. Applied the deforming force per unit cross-sectional area of that strain or area of that string, area of that rubber band or area of that string, which can be changes in their length. Then what is the longitudinal strain? Longitudinal strain. Before the discussions of the longitudinal strain, I will draw one of the diagram here. This is a point A. This is the rigid points, and one string or a rubber band or the thread will be suspended at a point A. Now I will try to apply certain weight on that string. After the applying the weight on that string, consider this is the original length. This will be the original length, that is capital L, and this will be increase in the length of the string after applying the weight of that object. Weight will be force. Then this will be change in a length or change in original length of the string. This is the delta L. Then the longitudinal strain. Strain, it is the ratio in which the change in dimensional to the original dimension. Change in dimensions is the delta L to the original dimension is L. We know that strain does not have any unit. All types of the stress will be same. The formula for the stress will be same because the stress is applied deforming force per unit area, and this will be cross sectional area below or the cylindrical area or circular area below the or end the string, end of that string. Then we apply certain stress of that string. There will be changes in their length. This will be change in length, the delta L. Original length will be caps L. Then the strain, longitudinal strain, is equal to change in a length to the original length. Then the second types of the stress or strain is volume stress. Volume stress on and volume strain. I will give one of the examples here. This is a spherical shaped spongy balls having the volume is a capital V. This is the spherical shaped sponge ball having the volume is caps V. When we try to applying certain deforming force on the surface of spherical surface of that ball, the length, the volume of the ball will be compressed, and then new volume The new volume of the balls will be this like. We'll call this small v. But these shaded regions is the change in volume of that sponge ball or spherical shaped sponge ball. This will be change in volume is a delta v. As we said before at the time of discussions of the longitudinal strays having the same equations or same things for each and every types, then the volume stays Vs equal to applied certain deforming force on the surface, on the spherical surface of the sponge ball, that is the force F divided by on the area, on the surface area of that spherical shaped ball. But strain will be changes. The volume strain is equal to the change in dimension to the original dimension. Change in dimensions will be delta V and original dimension is the caps V. Then the change in dimensions or change in volume to the original volume, this is the strain of or volume strain. If we apply certain force on the spherical shaped sponge ball, the volume of the ball will be changes. Then the volume strain is change in volume to the original volume. Then last one is the shearing stress or shearing strain. This is the most important, and the formula of each and every equations or each and every strain asking in 1 marks in any examples. Shearing stress or shearing and shearing strain. First, at the time of starting the lectures or discussions of these types of the stress and strain, I will shows the diagrammatical representation, shows one of the examples, taken a box of chalks and try to change the volume. This is the our diagram, original diagram here. This is the shape of cuboid box. This is the shape of cuboid box. When we will apply certain deforming force at the top edges, tangentially at the top edges, then the shape of that object will be changes like this. Shape will be changes. Then this is the white or this is the white length or white mark will be shows the original length, small l length of the surface area or length of the edge of the boxes, that is L, and smallest length will be changes here, that is delta L, or this is the total length and this will be change in length will be shows here. This is the change in length, that is delta L. Shearing strain, the tangential deforming force, the tangential deforming force applied, tangential deforming force applied parallel to the or applied at the applied top, which is parallel to bottom, and change the size, change the shape of, change the shape of object is called shearing stress, that is SS. What is the shearing stress? When we apply the tangential deforming force at the top of the boxes or top of the object, which is also parallel to the bottom. But why we are applying the top? But why we called the parallel to bottom? We can apply like this. It is also top, but the tangential force applied to that top surface, which is parallel to the bottom surface, then the shape of that object will be changes, then this stress is called as this stress is called as shearing stress. What is the shearing stress? If we are applying certain tangential force at the top surface which is parallel to the bottom surface, this will be responsible to the change the shape of the object. This is called as shearing stress. Then what is the shearing strain? Strain will be shearing strain equal to change in surface length, change in the upper surface length to the original length. Lot of students will be confusion between the shearing strain and longitudinal strain because they have the same notations, same letters of notations. This will be L, and the longitudinal strain is also L, but this will be capital L. This is the length of the string, and this is the only length of the edges or surface length only. Then, whenever we think about these two surface, this is our original surface, and this is the next time surface when we are applying certain deforming force or after the changing of the shape of that object, the angle will be made between these two arms. This angle is called theta. Then to finding the volume strain, to finding the shearing strain, then we can also find the tangential ratio of theta. Tangential ratio of theta. Then we can calculate the volume, the shearing strain. The formula for finding the shearing strain, if we use the angle between the original arm or original side of the shape to the change in shape, then we get the tangential of that angle and get the final answer, which must be asked MCQ or 1 or 2 marks. Just to revise before the rubbing of the boards, who will be discussed in that board. Longitudinal stress and longitudinal strains. The stress which is responsible for the change in length of that object, this is known as the volume stress. Sorry, this is known as the longitudinal stress. Deforming force is applied along the length of that object, which can be changes their length. This is known as a longitudinal stress. Longitudinal stress is applied deforming force per unit cross-sectional area. Then longitudinal strain, if we applying the certain deforming force along the length of the object, then the length of that object will be changes. Then the strain is the ratios in which the change in dimension to the original dimension, then change in length to the original length. This is the formula for longitudinal strain. The next one part is volume stress or volume strain. If we are applying certain deforming force, the object will be changes in their volumes. This stress or this strain is known as volume stress or volume strain. When we are taking one of the examples, that is spherical sponge ball, we are applying certain force on that ball. We are applying certain force on the surface of that balls. The ball having changes in their volume, and this is the responsible for the volume strain. Last one is the shearing strain. This is the change in length. This is change in size. This is also change in size, and this one be change in shape. We are applying certain tangential force to the box. The tangential deforming force applied at top of that box, which is parallel to the bottom, and change the shape of that object. This is called as the shearing stress. And the shearing strain, the original length or surface length of that object will be smaller, and change in smallest length will be delta L, and the shearing strain SS is equal to change in surface length to the original length, or such angle makes at two arm, which is original arm or which is arm or side before the deformations, one another side, if the change after the deformations or change in shape of the object, the angle makes both arm, this angle is theta, and we find the value, find the shearing strain, we can be take the tangential of that angles. This is all about the types of the stress and strain. Now we are discuss one of the laws which is responsible or which is gives the relationship between the stress and strain. This law is known as Hooke's law. But what is about the Hooke's law? You must know the knowledge about the elastic limit. Elastic limit. It is the extreme types of the force or deforming force. After we apply the more that force, then it can be breaks their plus elastic properties. Okay, I will use one of the examples. We taken the rubber band and continuously stretching the rubber bands. Rubber bands, it can be changes their length continuously when we can increase the deforming force, apply the deforming force. At certain times, the deforming force is more, and at that times the length will could not be changes. It is not able to change in length, and we are continuously increase the deforming force after some limits, the breaks, the length or the rubber band will be breaks. Before the breaking of that rubber band, these all types of the deforming force is known as is inside the elastic limit. It is the limit of it is the limit of deforming force. Deforming. It is the limit of deforming force. After that, the elastic body is converted to plastic body. The elastic body is converts to plastic body. Elastic body is converted to plastic body. It is the limit of deforming force. It is the limit of deforming force. After we applying certain deforming force, after that limit, the elastic body is converted to plastic body. Or this rubber band takes the permanent deformation. There will be breaks, and they have continuously changes or permanent changes in their length also. What about the